embedded systems, you have heard a lot of presentations today, and it's quite difficult, it's quite hard. So at Wibu-Systems, we try to provide tools, and we say what you build can only be as good as the quality of your tools. So we try to make the life of the engineers and the developers and the builders of systems a little bit easier by providing solutions for secure boot, IP protection, that means protection of intellectual property, integrity protection, and access control for software, source code, and data in embedded system. A big grand title in Thales tradition. So here we go. Wibu-Systems, has anyone ever heard of the company? 3. Well, that's about 10%. We've been around for almost 30 years. Founded in '89. I often get the question, where does the name come from? Well, we have 2 founders. One is called Winston Reed, and the other is called Marcellus Boegheid. They both studied in Karlsruhe, and they started with this software and protection and licensing product to encrypt applications and then make it easy to distribute them. And over the last 30 years, we have done nothing but that. So highly specialized, a team of about 100 professional individuals working full-time for the company with some subsidiaries across the world. Ken is one of those from representing Wibu-Systems in South Africa. But with a sole focus on software protection and software licensing for the past 30 years. So, what kind of solutions are we talking about? So we deliver tools to make sure that your secure key can be stored in a proper way, that you have security policies in place and license models, that your software licensing system gets integrated into your backend. I'll explain that a little bit later, with automatic software encryption and APIs, and the integration into your back office. And we have done those things traditionally for software that runs on Windows systems, desktops, machines with a lot of processing power, with a lot of memory power. And now finally, after a project of almost 3-4 years, I guess, we have ported like 89% of those solutions to the embedded world, which makes them available for IoT projects, making your life easier, in theory. So licensing, protection and security is at the core of everything we do. We have on top of that built some solutions to integrate it into your software. That means that, well, at the end of your software development suite, you have this build server, and integrated into this build server is just an automated process to make sure that the application that you've developed gets compiled and protected. And to integrate it into your back office, because you also need to move your product to market. So, what is the fundamental principle? What we simply say is, a part of your product is usually software, and this part is getting bigger and bigger. And so your software will once it gets compiled, will consist of executables or libraries. And basically we could have an encryption tool, a wrapper, or a protective solution that you can upload your executable, and it gets encrypted, and then you have a piece of protected software. And when we talk about protective software, we talk about the idea of having sort of a self-extracting executable, which only extracts if it can find a valid license. So this is the basic principle of what Wibu-Systems has done for the past 30 years. It's basically protecting the software with all kinds of methods. So we encrypt the software, we encrypt parts of the software, we use obfuscation, we use signing, we use all kinds of different methodologies just to protect an executable. But before the executable actually runs, it will ask, do I have a valid license? And if a valid license is found there, it runs. And if it doesn't, it says, well, I don't have the license, and we'd have an online license management tool in place to simply update the license and then the software can run exactly as intended. So, why do we do that? Why do we do the dual approach between software protection and software licensing? Well, at the company level, you have a department that develops products, or the R&D team, and you have a department that just wants to move the product. And those different teams, they have different objectives and different priorities. So the R&D team, they want to build products that work and that you can break apart and do anything with. And the business process wants to serve their customers. Because the customers might have different requirements and you might have different types of customers. So what can we do with our technology that's called CodeMeter? Well, you can maybe reduce the number of products by just batching it all together in one big protected batch and giving the whole batch to everyone, the smallest customer and the biggest customer. And it's the business processes, so it's for example a web shop, or it could be a CRM system, or it could be an ERP system that delivers different licenses, and that means that your customers can work with your products the way you intend to, and if they ever want to update or change a plan, they are easily able to, because you have the tools to just update the license. Well, what kinds of license can we think about? Well, all the license types that you can possibly imagine. So you can, instead of delivering a product, you could lease a product, you can trial them, you can trial specific parts of those, you can have grace periods, standby licenses. For every use case scenario, there is a different subset of license models that might apply to your use case.
Maybe what I'd like to just quickly jump in here, because this is quite important. You know, as a company that also develops software, what often happens is you go down the road, and being an engineer myself, so I know what it is. You like to build things that work, but often the engineers get to 3-4 months down the line, and the marketing guy says, well, I don't want you to build this thing monthly, I want a unit count on it. And the engineer goes, oh my goodness, I spent the last 6 months building it to be a monthly subscription model. Whereas this tool allows you very easy to change your licensing model on the fly without your software developers having to be involved at all. So yeah.
Yeah, which means that the market department, the marketing department and the sales department can define on the fly, as time progresses, new license models for essentially the same product. And that's making life for the product engineers a lot easier. So those licenses, they should be stored somewhere. So either you have room on your device to put a temporary system chip in there, to maybe use a USB-based dongle, but at Wibu we deliver a lot of different form factors to store licenses in a hardware way. So they all contain this chip. Our supplier is Infineon. They have this anti-tamper, this tamper-resistant smart card chip, which is protected against all kinds of differential power analysis, against all kinds of different attacks, and it's basically a very safe space to store a secret. So we have built-in security features, like, well, there is a license and there is a lot of very valuable information stored in these chips, and we have, well, from the firmware, a secure update channel, which means that you can change the way your product functions in a secure way.
I have another question. So we often deal in environments where there's virtual machines, virtual servers, where one of the issues you face is it's great. I mean, the technology works fantastically with the dongle. You know, plug the dongle in, it works, plug the dongle out, it doesn't work. Then you get to your Amazon Web Services and they say, there's no dongle here, bud. You know, there's nowhere to put it in. Do you have a product that solves for that problem?
Yeah, well, absolutely. Once a piece of software is protected, we don't really care how you store the license. We recommend, if possible, to use a hardware secure element, but you could also use a fingerprint of the system that the software runs on. And that could be a virtual environment, it could be an array system, it could be a laptop or a desktop, or it could be a license server somewhere. However, in the embedded world, we often work much closer to the hardware itself. So that means that you, as a product builder, you can determine there is a very specific serial number in the device that the software is running on, and you want to bind the software license to that element. It could be an EMI number, it could be the TPM chip, and it could be a range of things, basically free for you to set, as long as your hardware supplier supplies you the way of extracting that information. It's basically a 5-minute job to integrate it with a Wibu-Systems product. So the basic solution architecture is to integrate the security stuff once, to integrate it into your software. So we've got a whole range of different tools that would apply whether you would code your applications in a native language or in a managed or unmanaged code. It can integrate with your business processes, and it can easily be delivered to the user through an online method or through offline methods, depending on the use case. Because what we see, because this architecture is something that we have used for, I'd say, the past 20 years with a lot of success on standard systems. But now we are moving it into embedded systems, and there we see that the threats that we are accustomed to are really different. So, for example, even for the product builders, the threats and the risks are different than for the end users. For example, a manufacturer could have the threat that a complete machine or a complete product gets reverse engineered. However, the user wouldn't care about that. They just want his product to work in a way that is safe and it doesn't leak their data. So we see that there are different threats for the end users and for the manufacturers. And this is taken from a presentation that has a whole range of slides of every step in the process. Because for an IoT device, usually it never goes from a manufacturer to an end user, but there are OEM partners in place, and there is a whole chain, and everyone in those chains have different requirements. So what have we done? We've basically ported the way that software is finding a license through our runtime, and we have ported that runtime through to an embedded driver. And that means that we strip out all the functionality that is not required or that is not possible to run. Because in an IoT device, you usually don't have a lot of processing power, you don't have a lot of memory. So you want the driver and the communication to be as light as possible. So we deliver it often as a library, and even if that's impossible to use it, we will deliver the source code for you to run it. That means that you can even do that at an FPGA level. But still, the automatic protection tools would apply.
Can you give us some idea of the footprint size of the drivers in terms of the size of processor it can support?
The smallest one that I've ever come across is a 19 kilobytes. That is the extra load that is applied for a Rockwell project. But in theory, they want their IoT devices which are controlling PLC devices to run also in the network, where the license gets plugged from the network. But we could strip that out, and theoretically we could go to 64 kilobytes for the complete functionality. In theory. So the architecture that we have ported to the embedded world for CodeMeter is actually quite simple. Where you store your license can still be a dongle, or it can be a software license where you can either bind to a TPM, or you could create a host ID, which is an algorithm of different identifiers. You could still have the license run over the network, so we'd have the license somewhere in the LAN environment. And we also provide a runtime bridge, which is really key, because you want to be able to port your application and to bring it to, for example, a Windows environment, to make sure that you can run, rerun, and test your development and your programming and your application in a simulated environment. So here we provide a runtime bridge. That means that both the complete runtime or the embedded runtime can work in parallel next to each other. And the different functionalities are also in place. You can still cache licenses to make sure that applications can catch those licenses pretty quickly, so you don't have to go through the whole decryption process every time. You can do this with several applications at once. Basically, well, the API is a subset of the complete CodeMeter runtime. However, it's a very complete subset, so that means that basically everything that we've developed for Windows and for macOS can now be used to effectively protect and license applications in the embedded domain. So why is that necessary? Well, there are some threats that are ubiquitous, that are really everywhere. For example, if you would code in .NET or in Java, these intermediate language, your code can be disassembled pretty simply. Disassemblers are available from the internet freely, and it's really not difficult. However, if you would use a tool, the simple wrapper like Axe Protector, what we do is we keep the header always the same thing. So it means that your application from the outside still looks identical. And you would have different sections of the code, like the code itself, the source code, the data, and all the resources that come with it, that are encrypted. The AX engine, the security engine, is added on top of that, and that means that you have your protected application. Once that happens, try to disassemble that, you will get a lot of garbage, and you won't be able to do much with it. Basically, we are not saying that a CodeMeter application is uncrackable. However, we do say that in nearly all use cases, it's actually less time consuming to rebuild a complete application rather than trying to reverse engineer it. And it means that for the embedded world, we basically apply the exact same thing. However, with one difference, instead of needing the CodeMeter runtime for the application to function and find the license, we deliver on top of the protected application either the CodeMeter library or the CodeMeter source code to retain the license directly. So it's a bit abstract, but it also gives you the opportunity to make sure that your device boots in a secure way. Because if you have put an anchor of trust, for example, inside the TPM chip, CodeMeter can require your bootloader to verify that anchor of trust and only load the bootloader if the anchor of trust is found. And based upon that, you can go one step higher. You can only load the operating system once the bootloader is verified. Now, why is that necessary? Because you want to be sure that on your device, the operating system that you run is an original one, the authentic one, the one that is unmodified, and it doesn't run in some virtual environment to be extracted and to be looked at or modified. And the same goes for your application. The application will only run in the original unmodified operating system, and the application itself is also protected in its integrity. Of course, this is a static situation, but CodeMeter delivers the tools to make sure that every time we want to update one of those steps, it gets updated to a secure channel. I'm way over time. So let's have some examples. We see that traditionally big German industry companies are using our tools, like Codesys and Rockwell Automation, and also Wind River, which is not German. But all three of those, they are building IDEs. Those are development environments for software, and they integrate our tools to enable you that if you develop an IoT application on one of their platforms, you can integrate our tools directly. Infineon does the same thing with their Dave development tool. And I think you have some nice examples as well.
How much time do I have?
2 minutes.
Okay. That's good. That's good. The elevator pitch. So The application that we've developed and that we needed to get protection for, in the locking world, locks moved from a mechanical lock, combination locks, keys, then onto electronic locks, and then finally onto network locks. And the little device you see there in the middle is made by Dormakaba. It is the forerunner of IoT devices. Now, it's been around since 2008, somewhere around there, maybe even a little bit earlier, but it was a lock connected to a network, so it was a connected device. Now, here you have a problem in that obviously you don't want to be able to open the locks over the network, so there's a lot of checks and balances in place that you can monitor the locks, you can get certain information, because it's going a little bit towards where your car thing is. If you can get access to the locks and there's some magic command you could send down to the system, you could unlock a whole lot of bank vaults, which would turn into a big nasty. For us, the problem wasn't so much the locking systems, it was developing and protecting our software that was upstream from that, from reverse engineering, protecting our intellectual property. And we also have mobile applications that now allow us to do certain stuff, geolocating and opening the locks in a remote fashion, being close to the locks. So that's where Wibu came into play. They also protect Dormakaba's locking solutions, and they protect all our solutions in terms of being able to reverse engineer them and license them. So, that's a very brief shot on that. And then some of the things we're working on in the future, which is more for the thinking and then the engineers around there, is looking at stuff like watches, biometrics, tying threats to live data of security guards opening locks and looking at that whole solution. So, yeah, anybody that wants any more info, you can come and chat to us afterwards.